Hello everyone. The title of my talk is 6G to enable massive consumer robot. Here I would like to discuss the post-smartphone device for 6G. This device is the general purpose robot. And the key idea is for the consumer market. It is a 6G platform and it is universal and can be scaled to the largest market, that is the 2C applications for everyone at anywhere. The motivation for the theme of my talk is the future of the workforce. The workforce we meant here are the skilled and manual job. In the next decade, the shortage of the workforce in the developed country is inevitable. We could end up with a 65% of workforce availability. This situation is not only for Europe, United States, but also for many other regions. For example, Japan as a result of aging society, China as a result of a one-child policy. In the near future, the post-lockdown labor crisis is also an added factor to this situation. In fact, the lack of a skilled worker is another syndrome of a post-lockdown economy. The second motivation of my talk is the disruptive innovation on 6G. Let me give you a brief picture about 6G. In a 6G world, the physical world and the digital world will truly combine together. For the digital world, 6G is the sensing network for the physical world. 6G is also the neural system for the digital world to apply actions to the physical world. In our vision, in this sense, 6G is a new continuum between the physical world and the digital world. It is a new metaverse of intelligence. The mission for 6G is to create connected intelligence. What we envision in this talk is that in the next decade, we see a massive paradigm shift with the emerging massive intelligent robots, which means the era for the single-purpose dedicated robots is over. Today, the single-purpose robot can do limited tasks. The vision of the new world is an AI brain operating on a general-purpose robot, or even a humanoid robot. It is done by building the human mind cognition structure into a general-purpose robot. With this concept, we train the AI brain in a new way that human operating the general-purpose robot at the initial stage. This is the so-called human supervised learning. As AI brain evolves in a certain level of intelligence, the robot can take over to do the job automatically. This is not only a scenario for some of the specialized business. Our ambition is that this is also a consumer market. The robot is your personal butler. We are talking about a mass market size of 10 billion affordable robots. How to build general purpose robot? In fact, the general purpose robot is a dumb robot. Here, it has an AI brain. In other words, it is lean on the robot side while it is heavy on the AI side. At the Genesis time, the robot has little intelligence. The human workers start to teach the robot to do the real-world tasks. The human operation is treated as the ground truth for the deep learning of neural network learning. Now, a The AI brain can learn 70, 24, and 7 at everywhere on the planet as long as they have the 6G connectivity. More specifically, the 6G eMBB is used for the virtual reality, and the 6G URLC is used for transmission of the command to perform the physical action. The AI brain can be more dynamic with orchestration. Here, we actually operate robots to construct the AI brain for further expand into orchestration mini tasks. To make the robot smart, the AI brain plus the human labeled learning has 3 different phases. The first phase is to active AI experimental learning, that is the supervised learning. The second phase is the synthetic reflection and observations, that is to perform experiments on the digital twin. And the third phase is the abstract conceptualization from machine learning, that is the action for orchestration and the choreography. The key for this concept is the eventual unified platform for consumer market and to enable to invent the creation of millions of robot app. And especially such a platform can be used for create the niche use cases as well. The general purpose are shown, general procedure are shown in this chart. The first stage at the robot plus the 6G platform is generally used as remote driving style. It is a real experience, the human behind the scene to remote drive the robot to perform the task. We call this as a human pilot model. After creation time, a certain time, we get into a second stage. After the robot is trained, in this case, the human is only required to occasionally to handle the unexpected scenarios. In this way, we can operate the robot from the predicted scenes to more complex scenes to augment the use cases. Then we enter the stage 3, which we call the semi-autonomous stage. The robot on the 6G platform can perform most of the tasks with the basic skills. And the next stage is the transfer skills. This means that we start to allow many different subtle skills to transfer to the robots. And the robots can also do the tailor into the customized tasks. And finally, the robot can perform the no-man autonomous tasks. Single platform and single robot. In this way, the robot is just like an iPhone and truly universal. The intelligence of a robot is enabled through the cloud platform, and the AI enabled through the cloud platform as well. All the human tasks can be performed on this platform. The platform can imitate human brain dynamically and orchestrates visual, sound, touch, motion, and task planning. Even more, it can evolve into full autonomy as it learns the task and to learn through the experience like human. The AI brain platform can also enable all robots to learn each other. In this case, robot is an iPhone. We create an elastic, on-demand workforce. This also enables the scalability of the workers so that one person can do the work of many persons. Essentially, the worker becomes the supervisor, the robot becomes autonomous workforce. When you need them, you can call them in. If you don't need them, you can share with someone else. Let's consider the robots as an iPhone. Then the AI platform is an equivalent iPhone ecosystem. The robot contains so-called operating system which runs the app. For example, the app to program at the cloud to command the robot at home or factory remotely. The key ingredient is 6G. Here, 6G is like the operating system for iPhone. I'd like to elaborate this further. For 6G, in addition to transmit the bits, we can receive and detect the radio waveforms, and with advanced signal processing technique, we can detect the objects of signal parameter values such as location, velocity, and moving trajectory. We can also reconstruct the object imaging from the real-time environment learning and build into AI learning and inferencing service. Furthermore, we can analyze the spectrum of the objects, spectrogram of the objects, and sensing will be a perfect complementary for 6G to enable general-purpose robot. Using 6G sensing as a general-purpose sensor to unify all sensors and to use a single-purpose robot as of today. In addition, sensing is the source of massive data for machine learning, and it is automatically built in and with the same chip, same frequency spectrum, same air interface, and with a global unified standard. 6G integrated sensing and communication can be very powerful when using the sub-terahertz spectrum or terahertz terahertz spectrum to perform the radio sensing. A great potential to achieve the high resolution, high precision sensing while reaching the millimeter level of accuracy. By combining with the powerful signal processing technique, the 6G ISAC can see the objects and can perceive the shape of the objects and analyze the material of the objects. Here we list some of the physical limitations for 6G ISAC, defined by RB, Fraunhofer, and Rayleigh. With advanced signal processing technology, 6G ISAC can approach these limits. To make the general-purpose robot feasible, one of the key technical challenges is to use 6G ISAC as a terahertz camera. To use a terahertz camera to replace all specialized sensors to fulfill the same task that a single-purpose robot can do. We, as a human, to perform a job, we use all our sensors. Today, there are many typical sensors are used for robots. For example, contact sensor, tilt sensor, accelerator sensor, proximity sensor, distance sensor, gyroscope sensor, navigation sensor, position sensor. Our goal is to use 6G terahertz camera to replace all these sensors, to use a deep neural network for behavior learning and modeling, to make the 6G ISAC as a universal sensing platform. While 6G ISAC with the 6G ISAC technology, a universal global technology, we can make universal and affordable consumer robots to create the mass market. Their potential application is limitless. For example, hospitality service, cook-assist, housekeeping, remote health service, assisted living elderly, logistic, become a repairman, physical service, construction job. The key proposition is that to use 6G platform for consumer robot platform, and the consumer robot is simply 6 device as iPhone. On the 6G platform, we built robot ecosystem. the expertise for each business will transfer their domain-specific knowledge and the know-how to become a 6G APP. The creation of a 6G robot APP is where the expertise can make their business and profit. Let me finish my talk by showing a toy example for 6G ISAC-based general-purpose robot. This is a classical scenario for two single-purpose robots collaborate to finish a job, and they are programmed to do the job step by step. Here, the action at each step is called the mini task. The sequence of action for step 1, step 2, step 3, we call this orchestration or choreography. Our goal is to model these mini tasks and the choreography orchestration by machine learning on the 6G platform. Now, with 6G ISAC and especially 6G terahertz camera, we can perform the same task by interleaving the sensing and the communication in between the robot's actions and for mini tasks and orchestration as well. And to use the machine learning to learn and to analyze to inference the action of each robot to use 6G URLC connectivity to command the robots to perform the job. To highlight our idea to use 6G ISAC as a truly unified generic sensor to replace all the special sensors, we give an example for the tactile sensor. For ranging pressure, even the temperature, we can use ISAC sensor data in real time of the movement and the typical reaction of the robots from the interface inferencing result for the trained model. The back-end AI engine can, based on the so-called behavior modeling, to emulate the sensing and the action process, and therefore to achieve the goal that is to use a single type of ISAC and at many different positions to jointly compete tactile function. To wrap up, the takeaway message is a 6G consumer robot as an iPhone. The market potential is huge. For example, it is a $932 billion per year market for senior people care, in which the health and the Medicare is at 26% CAGR growth. Why 6G? The functional-wise, 6G will do sensing and communication of the sensing data and execution of actions. And why 6G? 6G is the global platform for connectivity, computing, and sensing. 6G can deliver AI service anywhere, anytime. 6G is the continuum of a 6G physical world and the digital world. 6G connectivity enables the perpetual learning and the universal inferencing service to all robots. On the 6G platform, robot will bring the service to you. You can order any robot you want. The instant service at home, office, cooking service Butler as a single universal robot. The instant doctor, instant nurse offers service with no time. Robot Butler become family and friends and evolve into next iPhone and personal assistants. Service of all your daily needs, leasing the robot Butler as a per price range of like a car or less, and finally robot will become your butler. With that, I conclude my talk. Thank you very much.